love technology. So for both parts, you'll get the whole time. Right? You shouldn't need the whole time, but you'll get the whole time of the class to complete each part. Don't come Thursday thinking we're going to have all the first parts graded. Good God. I should start grading, but I don't know if I'll finish. Yes? So today is whatever you guys want to focus on. We can do example problems. We can do specific problems. We can talk about ideas. If you looked at the practice final and anything looks weird and you don't remember how to do it, you can ask that right now. If you tried some problems and you had issues, you can ask about that. I don't know how many ways to say, you can ask any damn thing you want to from this semester, preferably. Yes? What I do is, I count each one as, let me see if I can make this make sense. Let's say there's a homework you didn't do. And extra credit homework takes the place of that. So if you do all the homework plus some extra credits, you'll have a higher than 100 homework average. So I just add it directly into the homework average. Yeah. Does that make sense? If there are 2 homeworks you didn't correct, that means they're each 50%. If you do 1 extra credit assignment, that would kind of fill that in. You know what I mean? Yeah. Also, I'm going to make sure to have some bonus from some of those extra credit sections. So we'll give you a little heads up on how to do some potential bonus on the final. I should have about 4 bonus questions, so it is possible to get 108 on this practice final. You guys with me? Did anybody not get their stuff back? What do I feel like? I don't know. Let's see. No. Okay. Besides dual. Oh, more so. Yeah. Yeah. Does anyone else need a practice final? Where did I put them? Here they are. Yes. Yes. Yeah. This is for both of them. This is we're taking one final, but we're going to take it over the course of 2 days. That's the way to look at it. So this is the practice final. You with me? Yeah. So it's one final, but I only got an hour and 20 minutes each time I see you, and that's not enough time for a final. So I'm just splitting it across 2 days. I don't know. Normally, somewhere in the 20s, 25 total questions. And of course, when I count questions, I count A, B, C, D. I had a teacher that said there's 4 questions on this quiz, and they were all A through J, and we're like, do you know how to count? So, okay.
Can you still turn the test corrections and
You could still turn in.
and report?
Could you still turn in quiz 1 corrections tomorrow? Or even Thursday? Could you get points back? Hell yeah, if you get enough of the corrections right, yes? And will that help you study for the final? I like how some of you guys are like, who knows anymore, Jeff? I do stuff, and I hope. But there's a method to my madness, or at least I think so. And of course, I'm the one in the madness, so who knows? But I try to make it so that everything you can do for points will help you. That makes sense to me. Yes? Okay. Can you turn in section 1.5 homework? That was our first homework assignment. Can you turn that in on Thursday and get credit? Of course you can. Will you get anywhere near as much credit as if it was on time? No. Will you get more than 0 credit? Yes. Why do I do such a thing? Because it will help you study. So of course I will give you some credit for that if you study. Lord. Maybe. Can you correct the final? No! Don't even call me. Can I come to your office? I've had somebody do, can I just come to your office and sit with you and we can look at the final? Blah, blah, blah. No. It's appropriately named. Very explanatory in just one word. Final. Okay. But again, I'm not trying to make you feel anxious about it. The great thing about the final, well, okay, there's a double-edged sword. I think I told you about this. Going into the final, you have about 75% of your grade locked in. So the final is worth about 25%, 20 or 25%, yes? So the final by itself can't do that much. It can save somebody from failing. It could take somebody from like a B plus to a B. I mean, you know what I mean? But it's not gonna like single-handedly destroy you. So it's also not gonna single-handedly save you from like a 50. Ain't gonna do that shit. You guys kinda with me? Okay. So on that grade sheet summary, it does tell you, give you a target as to what grade you need. Do I even remember to? Yes, I did. So everybody. Okay. That's what I'm talking about. Yes.
14.
Okay. Just-
5, 8.
Okay, so we'll do 5 and then 14. Let's see. Which one? 5 who?
5, 8.
E?
Yeah.
Okay, cool. So this was from the other day when a student asked me to kind of figure out what sections each of these were from. Which is a good question, right? So we'll do 5E. Let's see. Can somebody help me out with... So let's talk about motivation on this problem. I have a cosine and a sine. Yes? Those don't really work well together. There are 2 ways to do this problem. Could I replace sine squared with cosine somehow?
Yeah.
Totally. Is there a more, so I could go down that route. I could. In fact, we'll do this 2 ways. The most direct way is, what is cosine squared x minus sine squared x? What is that? It's not 1. It's never 1. What would it take to be 1? You have to add them, yes? Cosine squared plus sine squared is 1. Cosine squared minus sine squared is something else entirely. So what'd you guys say? I'm sorry? What is it? Double angle, sure. Which one? Good. Cosine 2x. So I need you to understand. Dear God, if you're going any further than this class, you gotta know your trig. You just have to. I'm teaching Calc 2 right now. From the beginning I've told them, you gotta know your trig, you should know your trig already. And to this day, there's still people that don't know the trig, and I'm like, God damn it, you're gonna die on these problems. You have to know your identities, you just do. And I try to give you several ways to kind of remember them. You got cosine's an asshole, that helps with a few things. Cosine's an asshole, so there's 3 ways to do cosine 2x, and this is the most fundamental way to do cosine 2x. Now, what the hell do I do from here? What angle is this problem talking about? What angle is in this problem? What angle is in there? 2x, kick ass. How the hell did you know that shit? Because what is inside of a trig function? An angle. So what's inside of the trig function in this problem? 2x. Now you come at me, Alexandra. What must 2x be? What must that angle be in order to make cosine 1/2? What must this angle be in order to make cosine become 1/2? You just said it. Pi over 3 is 1. Or what? What quadrants would have to be in for cosine to be positive 1/2? Yeah, either way. I think most of us might think 5 pi over 3 first, but you can also do negative pi over 3. They're the same dumb thing, yes? All right, let me stop for a minute. Let me stop. So when I see squares on my trig stuff, I think this could be an identity. Because not only do they show up in the Pythagorean identities, they also show up in the double angle identity, yes? So when I see squares, I stop everything and I go, do I have an identity in here? That would help. So the most direct identity you could use is the double angle identity. Then I just say to myself, this question is saying cosine of what is 1/2? Well, I know that shit because I memorized all that back when Jeff said I should. So then I know whatever angle is in here must be the angle that makes that true. It's either pi over 3 or 5 pi over 3. Now, if I want all the answers, what do I have to do? If I want everything this angle could be, that's not it, is it? How many more answers are there? How many? Infinitely more. Yeah, so hit me. What do I do with each one of these? 2 pi k. So again, that's my old reference to a commercial you guys don't get. It's okay. 4k. And then, what do I do? Why do I know I'm not done yet? Because I gotta get x by itself, yes? So whenever you have an equation, a trig equation, most often, if the inside is more than just x is 2x, 3x, 5x, whatever the shit, most often I'm not going to worry about that till the end. Now I can divide by 2. So if I divide by 2, I just put a 2 on all the bottoms, I get x is pi over 6 plus or minus pi k, or x is 5 pi over 6 plus or minus pi k. Right now, it don't matter worth shit if you copy all this down. What matters is, did you understand every step I took? Did you understand the idea behind the steps I took? That's understanding math. Why did I do it? Could you prompt yourself to do what I did? Can you let the problem itself tell you, hey, human up there, hey, this is what you do, man? Yes? Do it again, sorry.
Why did you do the double angle identity for cosine and not the sine?
Because what's sine 2x? What is sine 2x? Anybody? This thing that you have to know by tomorrow? What's sine 2x? You're all like, yeah, we know, Jeff, shut up. I don't know what to do. What's sine 2x? Anybody? That's the nice one. Yes? Sine 2x. 2 sine x cosine x. Yes? Sine twice theta is 2 sine theta cosine theta. That's the nice one. It's only got one option. Did I see that in here? Nope. If I saw 2 sine x cosine x, I can replace that with sine 2x. I saw cosine squared x minus sine squared, which is cosine 2x. It wasn't really a choice I made, it's a recognition. Oh, that's cosine 2x. Let me replace that. Now, do you see what beautiful thing happened then when I did from there to there? How many terms were here? 2, now there's 1. Now it's just a direct solving. I don't have extra crap I gotta worry about. Now, is that okay? I did say there was another way to do this problem. You guys want to see it? So, here's the other way to do this problem. There's actually 2 other ways, but the other 2 ways are basically the same thing. So what I could do is I could say, what is sine squared x? 1 minus So then I get cosine squared plus cosine squared minus 1. Let me add 1. Now I'm just doing all the normal solving equation steps, yes? So I used the Pythagorean identity. Why is this equation better than this equation? This one, right here. Is he delusional? You're like, you're not better than me. Why is he better than him? Why is the third dude better than the first dude? You can do it. Obviously better. Why?
There's only one thing to solve for.
There's only one piece that's true. There's only one piece with an x in it. I've kind of solidified where shit is. So let me solve for the x piece. What am I going to do next? Divide by 2. Then what am I going to do? Square root. And when I square root, I better put plus or minus. Square root of 3, I don't know. Square root of 4 is 2. Now, do you see the nice thing about this way to do it? What's my angle now? X. And what angle makes cosine rad 3 over 2? And then we'll worry about which quadrants we're in. What angle fundamentally makes cosine rad 3 over 2?
30.
Yes, give me better. Pi over 6. So pi over 6 works. What else works?
Negative 30.
Huh?
Negative 30.
Sure? Okay, we'll do it that way this time. Pi over 6. Negative pi over 6. What else works? 5 pi over 6. Yeah. 7 pi over 6. Oh my god. So I'm going to do this the silly way first, and then I'll show you a better way to do it. Are you guys all with me? Why could it be in every quadrant? Because it's plus or minus. So where's cosine positive or negative? Everywhere. What the hell are you talking about? They just have to have a reference angle of pi over 6 to make the number work, yes? Throughout the entire time we've been talking about trig, I've separated the sign from the number. We have the first quadrant stuff memorized. We know what makes cosine rad 3 over 2. Then I can go, is it positive or negative? That's what quadrant it's got to be in. So the silly way to write the answer would be, I don't have enough room. That's amazing, Jeff. Pi over 6, 5 pi over 6, where else is 7 pi over 6, and then negative pi over 6. You could also write this as 11 pi over 6 if you want to, yes? And then I would do plus or minus 2 pi k, blah, 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 blah. Does anyone notice anything about 2 pairs of answers here? Because I was nice to myself. I drew the picture. How far apart are these 2 answers? Pi. How far apart are these 2 answers? Pi. Now listen, if you write this, you're golden. It's correct. Move on. You could have written this instead. Pi over 6 plus or minus pi k, because then that would pick up this and this and this and this and this and this, yes? And 5 pi over 6 plus or minus pi k, because then that would pick up this and this and this and then backward, blah, 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 blah. Because I had answers that were equally spaced apart. I can catch more. Don't know if you get what I'm saying. You could catch all 4 and all of the things if I started each one and go all the way around. Or I could go, holy shit, if I just go halfway around and then I can catch 2 pairs, 2 sets of answers. So either this is an answer and it's beautiful and you won't lose any points, or this is an answer and it's beautiful and you won't lose any points. You'll just use less lead. That's right. Did I get the same answer we got before? Yes, thank the gods. Okay. All right. Maybe. My Calc 2 students are doing exactly this. Now, of course, this is the first step in a calculus problem, but they're doing exactly this. I need you to understand. They have to figure out where two things intersect. So they set up a trig equation, and then they do calculus shit after that. So this is a first step for their problem. Good for them. All right, well, it might be useful. Okay. Are there any follow-up questions to this? Do you want to do another example like this, or do you want to move on to something else? Or do you want me? Yes.
Are there gonna be any questions regarding matrices?
Hell yeah.
Could you show us one, please?
Sure, I guess so. There is this problem, where to go? Here, that actually on the answer key, this is one that I definitely want to do with you guys, because I didn't put it on the answer key. I didn't feel like. I didn't have enough time. Good Lord. So let's do that. That's the next question I got. So let's see. Are you guys, does anyone need to see this one done? It's always a weird, without a matrix, like just straight up. How would I solve this without a matrix?
You get X by itself and like plug it in and then you.
No. Sorry. You kind of could. In fact, there's a typo in this, I just realized. I love it. That should be what? I didn't mean to make this a trick question. Z. Okay. I'm not trying to be tricky. Elimination could work, it would just be more complicated. And elimination quickly goes to shit if I make this any bigger. Meaning right now it's 3 by 3, 3 equations, 3 unknowns. The minute is 4, 4, 5, 5. Forget about substitution. So I desperately want to use elimination. Can anyone tell me how to start solving this without a matrix? What do you mean by that? There you go. Not solve for it, but kill it.
Yeah.
Alright, pick a letter, kill it. Same letter, kill it again. Right? For some reason you have it out for this letter. Whichever letter, you don't like X because you're holding an algebra life, X has been giving you trouble, so just kill it. Or you don't like Y, screw Y. It's just sitting back and letting X do all the work. Or Z, screw you Z. Where'd you come from? So you pick whichever letter. This is very good psychologically for you as a math student. You get to kill some variables. Should be very cathartic. Is everybody, are you guys? All right.
How do you feel?
Huh? All right, let's do it. Do. Sorry. Where'd it go? There it is. I really hope this works out because I didn't even try it. We'll find out. We'll do it live. All right, so there's the problem, yes? Okay. So Khadijah, you said Y. Why'd you pick Y? Was there any reason? Yeah, I can see where it already wants to die. So you can pick whichever variable you want to start with and just kill it twice, right? Y looks to be the easiest to work with directly. Tell me again, you already told me once, but how do I kill it directly? Take the first equation plus the second equation, and of course that gives me 1 plus 2 is 4, so everybody knows. So if I add these two, what do I get? Yeah, I get negative x. These cancel. Minus z equals negative 1. Okay, we'll leave that like that for the moment. Now, can somebody else tell me how to kill y again? It won't be as straightforward anymore, but it's not that bad. I have to do one thing to make y die again. Can anyone see which two? Could you just? You're good. Just hold on. Can anyone see two other equations that are already kind of set up for y to die? 2 and 3, because they have opposite signs at least. Which one needs something done? Number 2. What do I multiply 2 by?
3.
That's crazy. The biggest mistake people make is they forget to multiply everything by what you're multiplying by. I'm going to rewrite 3 here. And what do I get when I add these together?
Negative 2x.
Negative 2x.
Is that a 9?
Yeah. Why is it a 9?
Negative 8.
Because I tripled that one. Yeah, so negative 8z equals
Negative 20.
negative 20. That is the 5th equation. Why are the 4th and 5th equations better than the first 3? One less unknown thing. Yes? If you're a detective on a case, what are you trying to figure out? All the unknowns. As you figure out an unknown, you're in a better place. How do I use these two to do something?
Multiple by times and add them.
Yeah, you could. I'm going to divide this one by negative 2. Because I can. I like to keep my numbers smaller. Because even though I'm pretty good at math, we're all human. Aren't we all? So this is the 5th equation. So now what can I do with the 4th and 5th equation?
Find x and z.
I can add them. So this specific problem doesn't mean shit. What matters is, why did I do each thing I did? I have 3 variables in the first place. Well, that sucks. If only I had 2 variables, I know what to do then. Alright, so then I construct a situation where I have only 2 variables. Do you guys get that? Don't just memorize steps. Understand why the steps work. What are they trying to do for me? Do you all agree with me that 4 and 5 are now much better equations? Because now, what do I do with 4 and 5? I add them, and I get the absolute best equation yet. And now it doesn't matter if you really understand what I'm about to say, but I always think dominoes. Now I got z to fall, I can go back 1, and I can get x to fall. Do you see I have a relationship between x and z? I've got 2 of them. So I can use either one of those to figure out what x is. Yes? No? Yeah, so now you plug z in, whichever one of those you want to. So plug z in here. X plus 12 is 10, subtract 12, x is negative 2. Become an equal sign and a negative sign. Right. Now what do I do? How do I know I'm not done?
You don't have y.
Huh? We don't have y. Exactly. So how do I get y? You pick any of the 3 original, because they're all relationships between x, y, and z. Doesn't really matter which one you pick. I'm going to pick the first one. So x minus y plus 2z equals 3. So you get 4 minus y is 3, so y is 1. Do it again. Oh, look at the first equation. The very first equation, number 1 equation. It says x. What's x? Negative 2 minus y plus twice 3 is 3. Now I can solve for y. As you get more information, you can plug it into earlier things. Detective. Talking to someone. I saw Joe and some other guy over there. Okay, who's the other guy? So I go over here and I'm like, oh yeah, this other Sam always hangs out with Joe at this time. Okay, so there was Sam. Let me plug that into this information. Now I know Sam and Joe were at this place at this time. When I learn later shit, I plug it into stuff I didn't know earlier. Yes?
So essentially you solve it by solving the first, the canceling that number by using the first 2.
equation, and then once you get that, then you do the last two. And then
No, it's just whatever works. Given, I mean, that made sense to us because these two are already opposite sides. If they weren't, maybe I'd use something else. Could I have eliminated the x from the beginning? Of course. Could I eliminate the z from the beginning? It don't matter. It don't matter. You're going to get those three numbers, whatever order you do it in. What's another way to write the answer? That's technically a little more, not correct, but more explicit.
2,
Negative 2?
2, 1,
1,
3.
3. Because now that's a point in three-dimensional space, which is geometrically what this means. It's where the three planes meet, the back corner.
So can you, what about the matrix?
Yeah, we'll do that next. Is how we doing with this part here. So now we know the answer is supposed to be this. So now when we do the matrix, go ahead, everybody set up the matrix for this if you haven't done that already. Yep, okay. So everybody got it? This is very different from synthetic division, but it's the same kind of idea to begin with. Just get rid of the crap that doesn't mean shit. All that matters is if I got all my x stuff lined up and my y stuff and my z, all that matters is the coefficients. So that should be what you get. What's the line here mean again?
Equal.
Equal. So this could be A's, B's, C's. We know it's X's, Y's, and Z's. Why is it important? If this is negative 2x, this should not be y. Why is that important? Why is it important that the first column is like all the x's? What am I about to do? What do I want to have happen? Let me take a step back. What's my goal here? What do I want to make this look like? I like when I force people to sound like they're little computer aliens. 10001000. Why is that my goal? Because then the first row says, it could be A, B, C, it could be W, Y, Z, I don't care. Yes? So let me ask this question again. Well, how do I get to that goal? Let me go this next step. How do I get to that goal? What do I do? Do it again. Good, beautiful, kick ass. I pick a column and then I make it look the way I want to. Yes? So that first column, for example, right? And it really doesn't matter. As long as you completely finish a column before you move on to another column, it doesn't matter which column you pick. Are you guys with me? So, do you guys, you okay if I start with the middle column this time? Just because? Just to show you it still works. What am I going to do here? What's nice about the middle column? It already has a 1 here, right? Now, are ones necessary? No. In the long run, what's necessary? What's necessary? Zeros. Cool. Because every time I get a 0, that means I killed a letter. If you think about it, this is the exact same work we did by hand. What did we do? We killed y twice. What am I about to do? I'm about to use that 1 to kill that and to kill that. Aren't I killing y twice? And now let me come back to my original question. Why is it important that these are the coefficients of x, these are the coefficients of y? I can't have z, negative 2y, and 4x. Why is that important?
So you can combine them.
So I can combine them. They just have to be like terms. So when I add a row to a row, I better have like terms. It's sort of like with synthetic division. I can't just put the coefficients wherever. It's got to be the cubed part and the squared part and the first power. Yes, it's got to be in that descending order. So what can I do? Pretty much just told you, but how do I kill this dude? Now I'm gonna make a 0 show up here. Yeah, take row 1 plus row 2 and put the answer where? Row 1, because that's where I want the 0 to show up. Hiya! So then this would become -1, 0, -1, -1. What equation is this? No, what equation is this? Translate it back for me.
Negative x
Negative x
plus
minus z equals -1. Yes? The middle row is not going to change. Now, here's the one thing I talked about before. Can I try to do two things at once here? How do I kill this guy? What do I have to do to this row? Multiply row 2 by 3, add it to row 3, put the answer where? Row 3, that's where I want the 0 to show up. So if I multiply this by row 3, by 3, this will be -6, 3, -9, -12. -6 plus 4 is -2. 3 minus 3 is 0. -9 plus 1 is -8. -12 minus 8 is -20. And of course, that is the other equation that we got. Whatever, guys. Is the middle column done? So I'm going to do one quick little thing. I'm just going to divide this by -2, just because. Hiya. So now you just pick another column. It doesn't matter which column you pick, as long as you finish that column fully. So I don't care.
So for every matrix, the middle column stays the same?
What do you mean?
If it's not the middle column, middle row, you always elevate.
Why did the middle row stay the same for us?
because
Why did the, yeah,
the
go.
the is it the x? No, the y variable was already 1.
That was already 1. I don't want it to change. In fact, I was using him to kill these two. So the row you are using to kind of kill some other piece won't change itself. Okay. And do you see now why? All right, I really want to. What happened here? What are these dumb little numbers? Remind me.
Sorry, row 2 times 3.
Yeah, they were. I just needed that momentarily. I need you to see. Do you all agree that this is much better than -6, 3, -9, -12? If I had that there. If I had that there, I would just divide the dumb thing by 3. I need you to see why I do this. I only need row 2 times 3 for a moment. And when I'm done with it, I would divide it back. So what I do is, I just don't write the whole matrix over and over and over again. I just put next to it, this is what you would be. I just need that for a second. Okay, maybe. Now, which column is most intriguing to you?
The fourth column.
Say this again. Which column that we need to change is most intriguing to you? Second one's done. We already finished the second column. So what I'm saying is, did we get the second column to look the way it's supposed to?
Yeah.
Okay, now which of the other two columns do you want to work on? That's what I'm asking. First one, okay, sorry. You're like, I don't know, man. What do you mean? Which one vibes with me? No. Which one do you want to do next? All right, so what the shit do I do here? I want it to look like this. Huh? There's even a better thing I could do right now, yeah? Yeah, let's just do that one. Row 1 plus row 3, put the answer where? Row 3, I love it. Alright, so then negative 1 plus 1 is 0. 0 plus 0 is 0. Negative 1 plus 4 is 3. Negative 1 plus 10 is 9. Now, let me see if you guys are cool with this. Is everybody cool with that, what I just did? Is everybody cool with that? Remember, tomorrow or Thursday, one of the 2 days, probably Thursday, you're going to have to be able to do all this yourself. So what you should be saying to yourself right now is, do I understand why he just did that? Do I understand what he just did?
So regardless of any matrix, the end goal is to always make it look like that.
Yes. Because if I can make it look like that, it literally says x equals this number, y equals this number, z equals that number.
Yep.
That is why that goal makes sense. And I need you guys to see. I'm not saying the game is necessarily fun. I'm not saying the game is necessarily one that you would play at home on your own time. But it does make this into a game. Find ones, make zeros. Find ones, make zeros. If you can't find a one, still freaking make a zero, because making zeros is the name of the game. I want to kill variables. If you do it a column at a time, what really sucks is if you don't finish a column and you move to another one, what you often do is you lose a zero that you gained earlier. And then you're playing whack-a-mole. I made a zero there. Made a zero. Yeah. So don't do that shit. If you finish a column out, those zeros are locked. Okay, maybe. What do I do now? I don't know. Yeah, what I would do is this. Let me see if you guys are cool with this. Is everybody cool with this? If I just multiply row 1 by negative 1? All right, now, how do I kill this? Because I want a 0 here, yes? How do I do that? 2 row 1 plus row 2. Put the answer in row 2. So let me put next to here twice that, twice that, twice that, twice that. 2 minus 2 is 0. 0 plus 1 is 1. 2 minus 3 is negative 1. 2 minus 4 is negative 2. And then the first row is still, yes, 1, 0, 1, 1. Do our first 2 columns look the way they're supposed to? Yes. Do I already have one answer? Yes. I got 3 things I need to figure out. We already figured out one of them. If I just do what? I'm just going to do it right here. Divide by 3. Is that cool? Is that all right? Maybe I'll write it again. Just to make it really clear what's going on. All right. Do you guys understand that if you miss one negative, or if you add 2 and 3 and get 6, the whole thing goes to shit? And that is very frustrating. But remind yourself, like 90% of the points will be given to you if you show me you know what you're doing. If somewhere you make a simple little mistake, I do that shit all the time. I'm not going to crack down on that. I'm going to take a point off. Yes? But if you finish it, you didn't get these funky ass answers, and you made one little mistake, I might not take any points off. Forgetting a negative is very human. It doesn't mean you don't understand what you're doing. It just means you had a human moment. I'm like, yeah. Okay, maybe. What kills me is when people have all this work and they erase all of it, and I can't quite make it out. I'm like, damn it, I don't even know if you would have got points. Shit.
Put a big X on it and start over.
Yeah, at the very least do that. So I can at least see what your work looked like, and I'll be like, oh, you made this one little mistake, and you were fine otherwise. I have something to work with. What do I do here? Does my last column look the way it's supposed to?
Yeah.
It does? No. And but good Lord, Jeff.
Just the
It's really nice this last row, yes? This last column, because they're all stupid ones.
3 to row 2.
Yeah, so if I add row 3 and row 2, put the answer where? Row 2, because that's where I want the 0 to show up, yes? So let's see, 0 plus 0, 0 plus 1, 1 minus 1, 3 minus 2. What else can I do?
subtract row 3 from row 1.
Yeah, let's try it. So let's do row 1 minus row 3, put the answer where?
Row 1.
Row 1. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 3 is negative 2. Is that the same answer we got before? I'm going to keep doing this until somebody says yes.
I said yeah.
Oh, you didn't? I didn't hear it. Alright. So that's how you read off the answer. Is it's just, if you make it in the form like this with the ones going down the diagonal, the answer just, you can read it right off. Negative 2, 1, 3, that's the point. X, Y, Z. Now, listen. How much did we work with matrices? How much did we do in this class? Barely a damn thing, yes? There's so much more beyond this. If I made, and I desperately want to, I almost wish I had enough time to do this, but I don't. Can you imagine this equation, but with 3 more unknowns and 3 more equations? Can you imagine doing that by hand? You pick a letter, kill it 5 times. Kill it again, right? Then you have a system of 4 equations. Now pick a letter, kill it 3 times. Now pick a letter, whatever, I can't remember what I even said. The thing with matrices is it just makes the game a little longer. Barely any longer. You find a 1, make zeros. You find a 1, make zeros. I don't care how big it gets. It doesn't get equally bigger in amounts of time needed. All right. You guys look thoroughly unimpressed, so I'll move on. Some good shit. This is some really good shit. But we don't even know, and it's okay. Oh, let me show you this. Before I forget, let me show you how to do this in your calculator. Need a calculator. If you look, get out of there, above your x to the negative 1 button, do you see a very intriguing word?
Mm-hmm.
If you go to matrix and you go to edit. Now, what size matrix is this completely? What size matrix is this?
3 by 4.
3 by 4. So I tell the calculator I need 3 by 4. And then you just fill it in.
You did 0.1?
Did I do it? Woohoo! Oh, I see what I did. Okay. And then, okay. Ba-bum. 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 Okay. So are you with me? I'm not going to spend too much time on this, but in case you want to check yourself on this problem, where'd it go? Oh, now I want to get out of my matrix. Second mode to quit. Get out of your matrix. Then you got to go back to matrix, and now I want to do math on a matrix. And the thing I don't think I said, which is not surprising to me, is the thing that we're actually doing is called row reduced echelon form. Oh my God. So when we do the 1s and the 0s, it means riff. That's what it means. It doesn't matter what the words are. Yeah. Row reduced. That makes sense. I'm reducing the rows in a way. Echelon. Anybody know what the word echelon means?
It means echelon.
It totally does, except on Tuesdays. In which case, no, it means tiered. Yes, isn't that what a matrix is? Row reduced echelon form. Okay. So if I just say do row reduced echelon form, you're gonna love this. Go back into matrix. Hit names A. Is that nice? Yeah. Now's where you say, why the shit do we do it by hand? Math boy.
Because we're not going to have a calculator tomorrow.
This will be on the calculator there.
Oh, okay.
So you will be able to check it if you want to. Tomorrow's no calculator, like I've said for a while. Yeah. 2 parts. First part, no calculator. Second part, calculator. Yeah. Okay. The calculator do a lot of shit. But we're the humans. We gotta understand what this shit is doing. And if you disagree with me, it's too damn bad. Okay. I love when I teach stats and somebody's like, my last stats teacher let us push buttons and get. I'm like, oh well, you don't got that person anymore. All right. Any other thing you want to go look at now?
14.
Oh yeah, I'm sorry, 14. I kind of started this one. Didn't I end up making conic sections extra credit? Is that right? Did I do that? Did I? I did, okay. I couldn't remember. Oh, that's why I did say this last time. So we did a little bit of work on it last time. If you multiply everything by r, that puts an r in front of sine theta. Why is that nice? Why is it nice to have an r in front of sine theta? What is that? What's r sine theta? That's y. What's r squared? X squared plus y squared. So then we're able to make it directly from polar to rectangular or Cartesian. Yes? What did I call it? Oh, rectangular. Okay, that's nice. I went so far as to say, what kind of conic section would this be? Well, why is it not a hyperbola? Why is it not a hyperbola? Anybody? What's a circle look like in terms of not like, if you do like this with okay. What's a circle look like for an equation?
I'm just guessing.
Unit circle, what is it? I'll get it started. X squared plus y squared equals r squared, which is in this case unit circle, x squared plus y squared equals 1. So things that are closed, circles, ellipses, have a plus. If I make it a minus, does that? If I add two positive numbers, neither number can get very big. If I subtract two positive numbers to become something, each one can get as big as it wants to. Do you remember that day we did that? How can I tell this is an ellipse? What's happening to the x squared piece? Yeah, what's happening to the y squared piece? Nothing. So does it act differently in the x direction than the y direction? Yes. So is it a circle or an ellipse? Ellipse. It goes further. Actually, this way, it'll go further in the y direction. Believe it or not. But like I said, when we did this together in class, I said I would do this first part could totally be a problem on the test. The second part would be a bonus. So I'm going to ask you to do up to here. Of course I could. But then the conic section question would be a bonus question. You guys catch my drift here? Get my meaning? Pick it up when I'm laying down? Okay. What the hell do people say nowadays? Do you still say that?
What do they say?
I just want to fully embody my oldness. I'll pick it up what you're laying down.
The Chileans say cachay, which is they speak Spanish, but they take an English word like do you catch that? And they say cachay.
That's what most people do nowadays?
No, just
Okay.
Chileans.
Yes. Thank you. Serenity. Serenity's like, let me just cut this shit. Well, which one, sorry? 5F. Oh yeah. All right, guys. What's the main idea with 5F? What would be cool if that stupid thing wasn't there? What if it was just that? What could I do? Put it into the washing machine. Yes? Why can't I do that here? There's 2 logs with the shit. So how do I make it become 1 log? A 1 log. Let's get together and solve some math. Yeah, what do I do when I have... What is it about these 2 that tells me I can do something with them? They're both base 3. So then I can rewrite that as log base 3 of...
X plus 2 times.
Now can I do the washing machine? Of course, because now I have 1 log. The 1 log equals a number. So I can do the washing machine. If there had been a minus in the middle, I would have divided the 2 things on the inside, yes? Now, once you do the washing machine, it becomes an old formula. multiply it out, make it equal to 0, refactor it, blah, blah, blah. What would the next step look like?
Rewrite it in standard form.
So it's 10,
Huh?
right?
3 to the third. Right? 3 to the third equals that. 3 to the third equals that. Now, can I just say either x plus 2 is 27 or x minus 4 is 27? Of course not. Neither one of these has to be 27. This could be 3, this could be 9. Yes?
Infinite.
Yeah. No, not really.
So
How do I do that?
x plus 2.
No. That's exactly what I just said. Give me two numbers that multiply to be 27.
1 and 27.
1 and 27. Two more.
3,
3 and 9.
5, and
Two more. -1, -27. Two more. -3, -9. Two more. 54 and 1/2. Two more. 540 and 1 over 20. Two more. I could just go all day, yes? And then the next day, until like that. Until like that. And then you have a seance and say, keep going, Jeff. So what's wrong with this dumb thing? What do I want over here? What number here, of course, restricts how many things can happen? 0. So the way I look at this problem, this is not true, but I pretend to myself, oh, some fool factored the damn thing to root. So let me unfactor it. Let me multiply this shit out. Suck the 27 over, and then factor, because now it will be equal to 0. So you kind of have to go backwards a little bit because it's factored too early. Yes? Maybe? No?
Yes.
So then x squared minus 2x minus 8, and then I subtract 27. Now I factor, because now it's equal to 0, and now that will actually go somewhere. The more you understand the idea behind what we're doing, the more you will remember what to do.
Then x,
Because then it's less doing what you memorize and more just doing what makes sense. Yeah.
so x minus 5, x minus 6, x plus 7.
Other way around.
X plus 7.
X minus 7. X plus 5. Then you get two answers, and you got to make sure that they both work, or that neither one of them makes the logs freak out. Yes.
By pulling back in.
2 others plus.
Yes. So let me give you the answer key before I forget to do that. There it is. I got to remind myself if there was something else. Oh yeah. I'm not sure why. Well, here, let me give this to you. There's one question nobody's asked me, but I thought for sure somebody would ask me about.
What's the question?
Yeah. It's the one that the other one I didn't feel like doing. This one. We don't have to do it if you don't want to. It's fine. But I didn't do it on the key, so I figure I should probably do it. All right. What's the first step on number 16? I'm going to kind of start to factor the bottom a little bit here as I recopy this. Are you guys cool with that? So this becomes x squared plus 8x minus 1 over x minus 1 times x squared minus 1, which is x plus 1, x minus 1, which is x minus 1 squared, x plus 1. Okay, if you don't get what I just said, do it yourself, you'll be fine. Real quick, you guys agree to get 1x minus 1 to come out? X squared minus 1 has another x minus 1 in it, and it has an x plus 1 in it. So I get two of these, one of those. how do I set up the form of the answer to this? A over? Do it again? Sure, fine, but you better put what? Plus C over X. Now, why were none of my tops like AX plus B or something like that? Why were none of them like that? Because what degree is on the bottom, not counting the repeats? First degree. X minus 1 is repeated, and that's linear, it's first degree. X plus 1 is first degree, so all my tops have to be 0th degree. And all 0th degree means is no x's. 0 x's, that's why it's 0th degree. Say again? From here. So real quick, what is 1/3 plus 1/9?
2.
Meh.
2
Meh. How do you do this? How do you do 1/3 plus 1/9?
Oh, okay, 4 9. Sorry. That's bad.
Huh? I heard 1/9 and then 2/9.
4 9.
So multiply by 3. I'm sorry, I can't hear you back there. 3/9 plus 1/9 is 4/9. Now, when you look at this, why is one of these have a 3 when the answer is over 9? Because it just did, yes? So where could 9 have come from? Something over 9 plus something over 3. Now, how does that relate to what we're talking about? Isn't this something squared and that's something, yes? Something squared and that's something. If x minus 1 squared is 9, this is 9 and this is 3. Okay. So when you have repeats, if I had a 5th power, how many terms would that generate over here? If I had something to the 5th power, how many terms would that make? How many terms did a squared term make? Not this guy, don't look at this guy. Just talk about the squared piece. How many terms did it make? 2. How many terms would 3rd power make?
3.
Holy shit. Yes? So I have to represent the power and all the powers down to the first power. Because something over 27 could have come from 1/27 plus 1/9 plus 1/3. Yes? Thing squared, thing cubed. What's the next step? Yeah, kill the fractions, which is always kind of cathartic. So if I just multiply both sides by this, here it all cancels. What's the shortcut over here? What's A going to pick up? Because what it has dies. What it has dies, so what does B pick up?
Plus 1 squared.
The x plus 1? I'm with you, Khadijah, but we'll just do this for now. And then what does C pick up?
X minus 1 squared.
And again, if you're not sure why, there, that's why. Whatever it has currently is going to die, and it picks up what else there is. That's a nice little shortcut you can create. Now, what is the option we can do right now if we don't want to equate coefficients? It's an option I have here because I can do something. What can I do? I can make x1, for example. Why making x1? Why does it help? Yeah, that dies, and that dies. And why is that nice? Because 2 of my unknowns go away, and I can solve for the 3rd one. So if x is 1, what is this? 1 plus 8 minus 1. And then over here I get 2a diet dead. Yes?
Why would you kill B? If you plug into X, that's gonna be this one, which is B, 2B.
What else is multiplied by me? What would that be? I don't care times 0 is 0. And of course C directly dies, right? Is everybody really actually okay with this? You guys alright? Okay. So what's A? 4. What would I do then? Can I do this trick again? Can I do this kind of thing again? Why was x equal 1 good? So what other x is good? -1. Okay. Do you understand? What are you allowed to make x equal in this equation? Any frickin' thing you want to. Am I trying to solve for x? No. What am I trying to solve for? ABC. What could x be? Any damn thing I want it to be. So I want x to be 1. Look what I get there. And I want x to be -1. Why am I picking those numbers? Because it makes some of the shit I don't know go away. Wouldn't that be great if we could do that in our real life? Very often the worst thing is when I'm not sure about something. If I can just make that go away, I'm like, ugh. So if x is -1, this becomes 1 minus 8 minus 1
So
minus 8.
0.
0, 0, 4c. Right, -2 squared is 4. So c is -2. I love you guys. So now, look. Can anyone tell me what my x squared, without multiplying all this stupid shit out, what would be in front of x squared? Can you guys see it? What would be in front of x squared here? Would a be involved with x squared? No. Bx squared, yes. Cx squared. So what must b plus c be? B plus c must be 1. Because the coefficient of the x squared better be equal to the coefficient of the x squared. What was b? We don't know. What was c? -2. So b is 3. So now you just put 4 over this, 3 over this, -2 over this. And then you're done. Now in Calc 2, that would be the first part of the problem. And then you do calculus to it. But we're not there yet, so that's the end of our problem right there. Okay. Did everybody get back their grade sheet summary and stuff? I don't think, yeah, okay.
You didn't hand them out today.
Oh, Serenity, you didn't get yours?
That's why I'm asking.
Let's see. Here. But just to let you know something, if you do have to take calculus, here's one thing about pre-calculus that I'm pretty sure you picked up on. You all agree with me, pre-calculus is dense in concepts. Did we do a lot this semester? Now, of course, it's 6 units, but to be really honest, even for a 6-unit class, it's really kind of dense in concepts. There's a lot in here. Calculus, sure, it's like on the next level, but it just takes what we do in algebra and takes it one step more, to be honest with you. To do that, though, it's got to teach a few other little things, but it's much more focused than pre-calc. Pre-calc, we do a little bit of everything until you literally go insane. Calculus, more focused. So if you're taking calc over the summer, it's really good. It's very focused. You can really kind of connect to it quicker and easier, and you have less time to forget it. You take it over the fall, there's a little more breathing room for other courses. It's not quite so dominating. Okay. I'm not trying to say it's easier than pre-calc, even though I do think it is. It's just a different way to think, and it's more focused on certain ideas. It's got fewer ideas in it, but it's got 2 really big ideas. All right, so. Anything else for now? Yes.
Is there gonna be classes
Oh, no, take Monday, you guys get Monday. Y'all with me? We're supposed to have class on Monday, which is supposed to be, our final is supposed to be on Monday. And I said no. Because I'm leaving town on Saturday. God damn it. I'm gonna take a week before I've gotta do summer class. Now, if you feel gypped, if you're like, that's a horrible thing to say, I'm sorry. If you feel like you were bamboozled out of some money, report me to my or my chiefs, right? I've had students upset that I did stuff like that. Sorry, you guys can go if you're ready. Go. But yeah, no class Monday. This Thursday is the end.
That's weird that the semester would end on Monday.
It's because this past Monday's a holiday. Yesterday's a holiday,
Okay.
so they feel it necessary to extend it.
Yeah, Mr.
Take care of it. What's funny is over the summer, July 2nd is a holiday, and I'm like, why?
What's July 2nd?
Nothing.
What's wrong?
So that's their 4th of July holiday, and I'm like, okay, that makes sense. 4th of July holiday on July 2nd, sure.
So you have these back to me, but you already have the 1 and 2 and 3, 4. I have them back to me. But you handed them back to me.
Oh, I suck. Let me 2, 3, 4. Let me make a note. Where did I put? Sorry. Line
Yeah,
2,
no, I
3,
still, I did this part good. I think I'm like really confident in this correction, but this one.
Line 2, 3, 4.
It's too much.
I
And I was like,
Cool.
So over here, how is this like all the turn in and okay? Is that like at this point, or is it just counting as like getting hundreds on the whole?
What do you mean? Sorry.
Like over here, you know how it says like all the homework turn
Yes.
in and okay?
This is what you would need on the final to get a B minus if you had all the homework turned in.
Yeah, but if I like, I'm turning it in right now,
Sure.
is it still the same amount I need to get on the final? Does that make sense?
If you have all the homework turned in,
But I'm turning it in now, not.
so therefore you're working in this direction. This just says right now if you had all the homework turned in. So if you turn in all the homework
Okay.
now, then
Yeah.
you're closer to this. Yes.
Okay.
So
that
then
makes
with my
sense.
4 bonus questions, that is definitely potentially
lock
true,
in.
possible. Yes.
Gotta lock in.
It's better than needing 117 on the final.
Is it okay? Then I think like other test corrections, you also accept that, correct?
Yeah.
Other
Like I said
quiz
earlier,
and
you could turn in quiz 1 corrections tomorrow
Yeah, I did.
and still get some points, not anywhere near as many points as you could have, but still
Like maybe 50% or less than that.
less than that. But still something.
Okay.
And it's studying for the final. That's
Exactly.
almost completely, yeah.
So I have a question about this.
Yeah.
How did this happen?
Oh, if I did multiply this out, it would be bx squared plus other shit. If I did multiply this out, it'd be cx squared plus other shit.
Yes.
So bx squared plus cx squared has to be 1x squared. So b plus c must be 1.
Okay,
Now,
gotcha.
if you can't see that, just multiply the shit out. But I'm just trying to show you. Without multiplying out, you know x times x is x squared, so bx squared.
So which are things like x squared? So
Huh?
similar coefficients?
Yes, whatever the coefficient is in x squared here has to equal the coefficients in x squared there.
And then this one would be 8x, right?
I mean, and then you get x's from here, don't you?
Yeah.
So it would be ax plus
Whatever x is we get.
whatever x is plus whatever x is, yeah.
Okay.
Okay. And that would equal 8. Okay. All right. Do. I am going to die. Do.